Hello guys, my name is Shreyas A. I'm an educator at Unacademy. You can follow me on the Learning app as well. You can see my new set of courses on the Learning app as well. So I have brought a new lesson. The lesson is namely the Calorimeters, which is under the course Energy Resources. So please do rate it, review it and share it. And please do subscribe us on our YouTube channel, that is the Unacademy Engineering Curriculum. Thank you. Let's start with the lesson guys, the elements of mechanical engineering. That is the course, the topic on which the courses are done. So my name is Shreyas A. I'm a BE Mechanical Engineering student. You can find me at the above URL here. That is my Unacademy user platform. And energy resources will be the slide or will be the course on which I'll be doing my lessons upon. So the target audience for this slide will be engineering students, general audience who are interested in science related topics, people who are interested in environmental resources, people who are interested in knowing the involvement of natural resources, as well as the learning outcomes of this slide will be, I'll be teaching basically the calorimeter, the types of calorimeter, the Lewis-Thompson calorimeter, the bomb calorimeter, and the Junkers gas calorimeter. So calorimeters, let's start with the first set of slides. So before going on to that, let's have a quotation. There is a very fine or thin line between genius and insanity. So if you have to do anything, whether you have to term that guy as genius or insanity, you need some measurements or you need some metric instruments. So that's what calorimeters are used of to determine whether the fuels are worthy of being a fuel, the resources are worthy of being a fuel or not worthy of being a fuel. So let's start with our lesson. Basically calorimeter. Calorimeter is the instrument which is based on the principle of calorimetry. So calorimetry is defined as measuring the heat of chemical changes or physical changes over the list of items which have been mentioned. So the uses of calorimeter are in the are in the sectors such as thermodynamics, chemistry and biochemistry. So you can see here basically the image representation of a calorimeter. How does a calorimeter actually look? So there are three types of calorimeter, namely the Lewis-Thompson calorimeter, the bomb calorimeter and the Junkers gas calorimeter. So let's start with the Lewis-Thompson calorimeter. This calorimeter is used for the purpose of finding the calorific value of a solid fuel. So we can use coal, coke or anything here. So firstly, the coal or the fuel, a potassium chlorate, potassium nitrate are separately weighed and mixed together and they are grinded in a crucible to obtain a smoother uniform mixture. This powdered mixture is poured into a small cylindrical metal container with a few matchsticks vertically inserted with their burning side projected out of a mixture side. The water is filled in the beaker up to the marked level, which constitutes around 2000 cubic centimeters of water. This the initial temperature where the water is filled is noted. The fuel mixture is then ignited and the container is immediately covered by the cylinder of the calorimeter. So you can see this is how the Lewis-Thompson calorimeter looks. You can see the stirrer over here, the thermometer, the reaction mixture happening over here and the nested insulated caps for stopping the reaction inside the calorimeter. So then there is a cylinder, it is covered by the cylinder of calorimeter. Then the whole apparatus is immersed in the beaker. The metal container liberates the hot gases. The gas gets accumulated in the beaker while the heat increases the temperature of the water. The final temperature is then noted. The heat liberated by the coal is equal to the heat absorbed by the water. So this is the calculation formula for the evaporative value of coal. So let's go on to our next thing, that is the bomb calorimeter. So this is the image representation of a Lewis-Thompson calorimeter, means how the Lewis-Thompson calorimeter actually looks. So let's go on to bomb calorimeter. It is used for determination of the calorific value of a liquid fuel, preferably diesel. So the procedure of this will be about 1 gram of the fuel is weighed in the crucible. A piece of firing wire is stretched between the electrodes in such a manner that it is in close contact with the fuel so that it can be ignited. Often solid fuel is made into pellets that can also be determined for its calorific value. The cap is then screwed down on the bomb and oxygen is filled in the cup to a pressure of about 20 atmospheric pressures. The bomb is then placed in a weighed amount of water taken in the calorimeter. The electrical connections are made, stirring is started, and the temperature reading is taken with a thermometer reading of 0.01 degrees centigrade. When the thermometer shows a steady temperature, the fuel is made to fire and the temperature readings are continued for a few minutes after the maximum temperature is attained. So you can see here the diagrammatic representation of a bomb calorimeter. You can see the thermometer over here. You can see the stirrer over here and the capsulations over here. So after the steady temperature is made, the water is stirred throughout the experiment, and then the bomb is removed and allowed to stand so that the acid mist may settle down. The pressure is slowly released and the contents of the bomb are carefully washed. In actual practice, correction needs to be made for the heat of the fuse of wire. So the heat liberated by the fuel is equal to the heat absorbed by the water when you are doing the experiment in a bomb calorimeter. So this is the image representation of how a bomb calorimeter actually looks. So this is the calorimeter present over here. This is the fuel gauge or the manometer gauge, which can be chosen over the things. This is the encapsulated capsule. So let's move on to our last calorimeter, namely the Junkers gas calorimeter. It is used for determination of calorific value of a gaseous fuel. The procedure is as follows. It ensures the continuous flow of water through the water jackets and passes the measured volume of gas to the gas meter. It helps in adjusting the pressure regulator for uniform flow of gas and record the manometer reading. It helps in recording the inlet gas temperature and cooling water temperature at the inlet. It also helps in the ignition of the gas using the burner. So this is the diagrammatic representation of a Junkers gas calorimeter. You can see the thermometer placed over here, the gas meter, the encapsulated capsules. The calorimeter doesn't require a stirrer as it has overflow. You can see here the cold water is made to flow into the apparatus setup, so it doesn't need a stirrer for the stirring of the fuel present inside. Then once the ignition of the gases is done, it ensures complete combustion and then records the amount of gas which is taken to heat the 2000 cubic centimeters of water, and then the final temperature of the water is noted down for the calculative purposes. Here also the heat liberated by the gas is equal to the heat absorbed by the water. If this statement is fulfilled, then you can tell the gas or the fuel which I have used is highly calorific. So this is the image representation of a Junkers gas calorimeter. This is how it will be there, and it requires electrical connection also. You can see the electrical appliances over here. So thank you guys. Any questions, please drop those in the comments box below. You can find me at the Unacademy user platform presented over here. And if you have liked the presentation, then please do rate this course, review this course and recommend this course. And please do follow me on my Unacademy user platform. Thank you guys. Have a good day.